question. Hello children, welcome back. We'll be continuing with exercise 8G of our book. Few students have requested me to solve few more important questions. Okay, now let's see few more important questions of 8G exercise. It's exercise 8G. Okay, now see, it's a very good question. Question number 19. It's differentiate tan inverse x upon under root of a square minus x square. Okay, now we'll let this as let y equals to tan inverse x upon under root a square minus x square. As I told you in the beginning, see, this question we have to solve by substitution. Okay, now you see here tan inverse x upon under root of a square minus x square. So we need to get rid of this a square minus x square. And we saw in the beginning when we have this type of expression, we prefer to put x equals to a sin theta or a cos theta. So here we'll put x equals to a sin theta, right? Or theta will be x sin inverse x upon a. This we need at the last to resubstitute the value. Okay, now okay, so we'll have now y equals to tan inverse a sin theta upon under root of a square minus a square sin square theta. Okay, now what we'll get? Tan inverse a sin theta upon a square will take common, then we'll get 1 minus sin square theta, that is cos square theta. Okay, so this we are going to get tan inverse a sin theta upon a cos theta. Okay, a will cancel out and this will get tan inverse tan theta. Okay, so this tan inverse tan theta, you know, this is going to be theta, and now this theta again we are going to resubstitute the value that we saw in the beginning, a theta equals to sin inverse x upon a. So here we'll put y equals to theta will be replaced by sin inverse x upon a, and now we'll differentiate this with respect to x. So we'll get dy by dx equals to 1 upon under root of 1 minus x square upon a square into, here we'll apply chain rule now, so we'll differentiate this x upon a, so x upon a will become 1 upon a. Now this will just simplify, here LCM will take, so it will become a square minus x square upon a square. A will take to the numerator, so a upon a square minus x square into 1 upon a will cancel out, so we'll get dy by dx equals to 1 upon under root of a square minus x square. Okay, now see, again we can see tan inverse x upon under root of a square minus x square, this has become very easy by substitution. Okay, now let's take another question. Okay, next question is question number 22. Let y equals to under root tan inverse under root a minus under root x upon 1 plus under root of ax. Okay, now see, this is a little different question and it needs little different treatment also. Put a star mark over this question. Star mark is for not only for that it is important, but it is also different one also. Okay, so before that I want to tell you one identity, that tan x minus y equals to tan x minus tan y upon 1 plus tan x into tan y. Okay, this is one identity. I hope we all know it, otherwise you just write it. Okay, now what we'll do, we'll put root a equals to tan alpha. Okay, that means it will give you alpha equals to tan inverse root a, and root x will put as tan beta. So beta equals to tan inverse root x. Okay. Now we'll put this value in the given expression. So we'll get y equals to tan inverse root a is tan alpha minus tan beta upon 1 plus tan alpha into tan beta. Okay, now if you compare this expression with the standard one, this one, so this I can write as tan alpha minus beta. Okay, so y equals to tan inverse tan alpha minus beta. Okay, so what do I get now? Y equals to alpha minus beta. Okay. Now replacing the values, alpha I'll replace with tan inverse root a, and beta I'll replace with tan inverse root x. Okay, now we can see root alpha, this is constant and this is a variable. Now we'll differentiate with respect to x. So what do I get? Dy by dx equals to, this is constant, so I'll get 0 minus this one 1 upon 1 plus root x square, and now we need to differentiate root x also using chain rule, so I'll get 1 upon 2 root x. So dy by dx equals to minus 1 upon 2 root x 1 plus x. Okay, clear? Now let's see another question. Okay, now let's see another question. Question number 23. Question number 23. This again will let us y equals to tan inverse under root of 2 minus x upon 2 plus x. Okay, now can you tell me what we are going to substitute here? We'll substitute x as 2 cos theta. We'll put x as 2 cos theta. Okay, so x by 2 equals to cos theta, and theta equals to cos inverse x upon 2. Okay, now let's see what do I get. We'll get y equals to tan inverse under root of 2 minus 2 cos theta upon 2 plus 2 cos theta. Okay, so equals to tan inverse 2 can be taken out as common. 2 common. 1 minus cos theta upon 2 common. 1 plus cos theta. 2 will cancel out. Then tan inverse 1 minus cos theta is 2 sine square theta by 2, and 1 plus cos theta is 2 cos square theta by 2. 2 will cancel out, and this is tan square theta by 2. So tan inverse under root tan square theta by 2. We'll get tan inverse tan theta by 2. Okay, we'll get theta by 2. Now again we'll resubstitute the value. Theta is cos inverse x by 2, so we'll replace that. Y equals to 1 by 2 into cos inverse x by 2. Now we'll differentiate this. Dy by dx equals to 1 by 2 minus 1 upon under root of 1 minus x square by 4 into, and this again we have to differentiate, so we'll get 1 by 2. Now we'll simplify. 1 by this 4 into LCM here minus 2 upon under root of 4 minus x square. Okay, so this will be cancelled out. We'll get minus 1 upon 2 under root of 4 minus x square. Okay, I hope this is clear. Okay, now let's take another question. This is question number 23. Now let's take another question. This is a little different one. Question number 24. Let y equals to sine inverse 2 raised to the power x plus 1 upon 1 plus 4x. Okay, can you think about what we are going to substitute here? See, there is one formula, I'll tell you, inverse trigonometry formula. Sine inverse 2x upon 1 plus x square equals to 2 tan inverse x. Okay, this is one identity of inverse trigonometry function. Sine inverse 2x upon 1 plus x square equals to 2 tan inverse x. Now let's see the question. Y equals to sine inverse, we can write 2 raised to the power x into 2 upon 1 plus 2 raised to the power x square. Can we write like this? Okay. Now I'll put 2 raised to the power x as t. Okay. So what do I get now? Y equals to sine inverse 2t upon 1 plus t square. Okay, now if you observe, this form is exactly same as this standard formula. That means sine inverse 2t upon 1 plus t square, okay, can be written as 2 tan inverse t. So I will write y equals to 2 tan inverse t. Okay, now this t I will replace with the original form, y equals to 2 tan inverse 2x. Okay, now we'll differentiate with respect to x. Dy by dx equals to 2 1 plus 2x whole square into this will differentiate. So what do I get? 2x log to the base e 2. That means I can write it as dy by dx equals to 2 raised to the power x plus 1 into log e2 upon 1 plus 4x. Okay. Now this was question number 24. Okay, let's try one more good question. That is question number 26. It's question number 26. It's given y equals to tan inverse 1 plus a square x square whole under root minus 1 upon ax. Okay. Now what we are going to do here is we'll put ax equals to tan theta. Okay. So theta equals to tan inverse ax. Okay. Now let's see, y equals to tan inverse under root of 1 plus tan square theta, because ax is tan theta, so a square x square will be tan square theta, minus 1 upon tan theta, right? So what do I get? Y equals to tan inverse 1 plus tan square theta is sec theta, so sec theta minus 1 upon tan theta. Okay. Now see, it's quite obvious that we want this expression to be tan theta, right? So we'll reduce it. Okay, we'll simplify this one. So y equals to tan inverse. This sec theta can be written as 1 upon cos theta, and 1 upon cos theta minus 1. That means 1 minus cos theta upon this sin theta upon cos theta. Cos theta will cancel out. So what is left is sin theta. Okay. Now y equals to tan inverse 1 minus cos theta is 2 sin square theta by 2. Okay. And sin theta can be written as 2 sin theta by 2 into cos theta by 2. 2 cancels out, sin theta, 1 sin theta will cancel out. So what is left now is y equals to tan inverse tan theta by 2. Okay. Now we'll replace this theta with this tan inverse ax. Okay. So y equals to theta by 2, that is 1 by 2 into theta will be tan inverse ax. Okay. Now we'll differentiate this. Now we'll differentiate this. So what do we get? Dy by dx equals to 1 by 2 into 1 upon 1 plus a square x square into differentiation of ax will be a. So what do I get? Dy by dx equals to a upon 2 into 1 plus a square x square. Okay. Now see from here, we have put ax equals to tan theta, then theta equals to tan inverse ax, this for resubstituting of the values. Now if you substitute Ax equals to tan theta, what do I get? Tan inverse 1 plus tan square theta minus 1 upon tan theta. 1 plus tan square theta is sec square theta. Under root, with under root it will give you sec theta. So sec theta minus 1 upon tan theta. Now simplifying this, will get 1 minus cos theta upon sin theta. Now here we have written half angle formula, simplifying tan theta by 2, and then we got this. Thank you.